Well, hello and welcome back. This is episode 2 of setting up a first-person survival game. Where we left off, our player had been able to look at interactable objects. One thing that has been annoying me is this here error. This is happening because the onDraw method runs inside the editor and the cam transform variable doesn't fill until the game is running. So it's giving us a null reference. Let's just fix this real quick. Let's change the way that we get our reference. Back inside the code, we can make it a serialized field and remove our onEnable and setInitialReference methods. Now, when we get back into the game, we can manually assign it. Okay, that should get rid of all these red error messages. Now, let's get into it. To start, we'll make up a parent script that all the interactable objects can derive from. This is a great way of giving all our interactable objects a base structure. Let's create a script and we'll call it interactable. To start, we can give the script a virtual method called interact. We make this a virtual method because it is made to be overwritten by all of its children. It's okay if you don't quite understand this, but once we start using it, it will make more sense. Basically, it's because we want the different interactable objects to all be able to do their own unique things when interacted with. Say you have a fire and interacting with it could open up a cooking display. But on like a stick on the ground, interacting with that would just pick it up. Okay, to start with, we just want to display a message on our console so we can see that it is functioning as we expect. And since next on our agenda is the inventory, it would make sense to create a pickup item. Let's make our interactable object a pickup item. To this end, we will need a script called pickup items and attach it to our queue. Okay, now let's open up our pickup item script and give it some functionality. To start with, we want the pickup item to derive from interactable. Now you can start to see the power of the overrideable method. We can give it a base functionality that all the children classes inherit, and also have it give unique properties. So to start with, this interactable object will just say it is picking it up when we interact. I would quite like for the script to give a message to our player indicating on screen that they have an option to interact. I like to use the E button as a good interact button. This is a very common button. Let's give a display. In our script we can add a unique display. Here we can give it a default display message in the base interactable class. Now if we open back up our project, we can see that our pickup item script inherits that interact message. But importantly, we can also change it here to say press E to pick up. Let's display our message on the screen. To do this, let's create a text object to hold our message on the screen. We need to import the TMP Essentials to have access to TextMesh Pro. Next, we should put our display on 2D mode and focus on the canvas by pressing the F button. Now we can see our text. Let's position it in the upper center portion of the screen, and we can anchor it to the upper center. Let's give it a width of 350 and then center the text alignment on both axes. That's nice. With this default message, we can get a good idea of how it will look. Okay, since this is a dynamic text object, let's make sure that it auto-sizes to fit in our rect transform space. Lastly, let's organize this a bit by giving it a meaningful name. Notification text will work fine. Now we can use this message to display any message we want the player to see during gameplay. Let's go ahead and disable this object for now, and we'll use code to enable and disable this object so it only shows up when we want it to. Alright, now let's talk about how we should do this. I like to have a game controller in my game. The game controller kind of directs traffic. In this game controller object, we can have a UI controller component that takes care of everything related to the UI. This way we can compartmentalize our project to help keep bugs under control. That being said, let's do this now. Create an empty object in the hierarchy window by right-clicking and selecting Create Empty. And let's name it Game Controller. Next, we'll add a new script that will act as a governing body for our game and call it the Game Controller. Let's edit this script. Since the game controller will be referenced by a lot of scripts, it would be great to have easy access to it. We'll start by creating a singleton pattern for it. This is done by creating an instance. This may look strange if you're new to the C# language. The whole idea of it is that we will create an instance object of the type game controller that is both public and static. So now in other scripts we can get reference to this by typing gamecontroller.instance. In the awake, we make sure that it is the only copy of the instance by destroying the game object this is on if there's already an instance. This ensures that there will only be one copy of the instance at any point. Now we'll set up some events. Let's get this all down and I will walk you through how it works. This is a powerful system that helps organize and run a game. We make a delegate with public delegate void general event handler. After the delegate is created, we can create an event of this type, which we will call onPlayerFocusEvent. Next, we need a way to call this event from other scripts. We write a public method that we will call callOnPlayerFocusEvent. This method will call this event, but we only want to do that if there is a subscriber to the event. So we need to check if the subscriber count is at least 1. This can be done by seeing if the onPlayerFocusEvent is equal to null or not. The shorthand way of doing this is onPlayerFocusEvent ? This does the same thing as if onPlayerFocusEvent does not equal null onPlayerFocusEvent. So now let's put this to use. In the player script, we create a variable for the object the player is currently focused on, or a focus object. Then we'll set up a variable to hold the reference to the game controller. I like to set this on the onEnable built-in method. We will put in the setInitialReferences method to get this reference and assign the controller to gamecontroller.instance. You can see how easy it is to get reference here. There can be some issues with this trying to call this reference before the game controller is executed into the memory. To help avoid this, I like to change the default execution order of the instance objects and put it at a negative number, like say -100. This will ensure that this script is executed first, so when other scripts try to get a reference to it, it is available. Great, so now back in the player script, let's make it so that when we get into range of an interactable object, instead of just printing to the console, let's set this as our focus object and call the onFocusEvent. And actually, I would quite like to pass the focus object on to the onFocusEvent. Luckily, this is easy to adjust. Let's go back into the game controller script and make this happen. Let's set up a new delegate that handles game objects. We'll pass in the game object as an argument. Now change the onPlayerFocusEvent to the object event handler. And finally, update the callOnPlayerFocusEvent so that it takes in the focus object and passes it to the focus event like this. We'll still need the general event handler for other events, so we won't rewrite it. In fact, While we're in here, let's make a general event. We will need the onDefocus event. So we followed the same structure as before. Create the event using the general event handler since it has no arguments. Then we'll call this event with a public method called callOnPlayerDefocus event. And in here, as before, check to see if there's anyone subscribed to this event. And if there is, then invoke it. Alright, perfect. Now we have a way of focusing and defocusing and letting everyone know about it. Events are very powerful. Back in the player script now, we only want to change the focus if the focus object is null, or if the focus object is not the same object we are currently looking at. Now, if our raycast does not hit an interactable object, we want to defocus. So we'll call the defocus event and set our focus object to null. Okay, we've written a bunch of code. Let's see if we have some functionality now and make sure it's working like we expect. So we want to see that when we look at an object, it becomes our focus object. And when we stop looking at it, we lose our focus object. Okay, since our focus object is a private variable, we need to put our inspector in debug mode so we can expose its value. Select the player and right-click on the inspector tab and change it to debug mode. Now you can see our focus object exposed for us to see the value. Alright, now let's start the game and see if it updates. Alright, great! You can see that when we look at our interactable object, it places that object in our focus object, and when I stop looking at it, it removes our focus object. Now let's make it update on the screen. Since we set up the events this way, it'll be a snap. Let's make a new script on the game controller called UI controller. This will take care of all of our UI activities. In the UI controller, let's get access to our game controller. We'll set up our same template in the onEnable. We'll call the setInitialReferences method, where we set the controller to the gameController.instance. Now, in the enable, we can subscribe to the onFocus event of the controller. Now when this event is triggered, it'll play all the methods subscribed to it. We will subscribe a method to display the notification text. When you subscribe to an event, you also need to make sure that you unsubscribe from it when and if this object is disabled to avoid errors. So, when you subscribe to it, always unsubscribe in the disable method. Okay, now to update the notification text, we need access to it. We'll set up a text object variable that we can assign in our editor by exposing it using the serialized field functionality. Now, in the display notification text method, we set the game object this text is on to active, and then we update the text, and since we have access to the focus object, we can use this access to get the interactable component and the unique interactable message that component has. Great, now let's make a way to get rid of this message. To do this, we simply need to subscribe to our onDefocus event and create a method to hide the notification. In the hide notification method, we just set our text game object to setActive false, and that should do it. Okay, back in the game, let's make sure to assign the text mesh notification text to the UI controller. And now let's play this and see how it's looking. Okay, look at that. We look at the object and we get our notification telling us to press E to pick up the pickup item. But of course we haven't programmed that yet, so that is the next step. But when we look away, it erases the message, like it should, and it brings it back when we have focus back on the object. This is great. I just realized we do have an issue though. We are currently defocusing all the time. We are not looking at an object. This is inefficient. Let's go back in the player script and only defocus if we have a focus object. Back in the player script, we'll do this check. Great. Now this is only defocusing if we already have a focus object. Now let's take a look at what happens if we have several focus objects close to each other and make sure that we're correctly shifting between the focus objects. Back in the game, we can add another pickup object, and we'll change the notification text on this one to be unique. We'll stack the two so they're right next to each other. Now let's see if it changes the notification when we move between the two. And nice! That's working well. And you can see that the defocus event is still functioning great as well, turning off the notification when we stop looking at an object. We finally made it. We have everything in place to start working on our inventory. There are so many inventory types to choose from, but I think for our purpose it would be best to stick to something less complicated. We'll go with a static inventory that can hold a fixed amount of items. Lots of games include encumbrance components, but that's beyond the scope of what we're trying to do today. So we're just going to stick with a fixed inventory amount. To start with, let's go create our inventory panel in our UI canvas. Let's go ahead and rename this to Inventory Panel. And we'll anchor it to the upper left of the canvas. Now we can make this any size, but the size I came up with is a width of 291 and a height of 410. Okay, this looks pretty good. Now let's position it to the left side of the screen so it's out of the way for our gameplay. Later we can go over toggling this on and off during gameplay. I've included a link in the description to get access to the images I'm using in this tutorial. You're free to grab them and follow along. Let's go ahead and load in the images. Just go ahead and drop these into your asset folder. I like to create a subfolder called Images and drop them in there to keep things organized. Alright, let's set these images up to be used by our UI. Click on the image in your asset folder and you'll see in the inspector a bunch of options. First, let's change the texture type to Sprite 2D and UI. Next, change the sprite mode to single, and we'll set the max size here. On our inventory panel, we look at the size of the image and set it to the closest max size, in this case 512, and then we apply these changes. We can do the same for the inventory slot image, Sprite 2D and UI, sprite mode single, and now max size is 64. Okay, now apply, and these images are ready to use. Let's go into our inventory panel and we can assign this image as the image. Go into the color here and up the alpha to 1 so it's not transparent. Now let's create another panel inside the inventory panel. Let's call this the inventory container panel. Let's dock it in the upper left and set the anchor to the upper left of the panel. Set the X pivot to 0 and the Y pivot to 1. Then set up the rect transform as follows. Position X at 14, position Y at -70, width to 263, and height to 330. For the image, let's leave the default background image in place, but change the color to black and up the alpha channel a bit. This will give us a nice translucent black backdrop for our inventory slots. Finally, click on the Add Component button and search for Grid Layout Group and add it. Set the cell size to 62 by 62 and the spacing to 5 and 5, and we can leave everything else the same. The Grid Layout Group is great for an inventory. It takes all the children of this panel and sorts them. Now we can create an inventory slot, which we can do by adding an image child to this inventory container panel. Let's assign our inventory slot image to the image, and when you do that you can see it drops neatly in the corner. If we add more, just by pushing Ctrl D to duplicate, it starts to populate the inventory slots in a nice orderly fashion. Alright, enough of that. Let's erase all but one inventory slot and make sure it's fully functional before we duplicate it. Now each of our inventory slots are going to need certain components to make them functional. let's add an image that we can use to display the item in the inventory. We can call this the item image and go ahead and disable it. This will only be shown when there is an item in this slot. Next, we can add a quantity value and an item name text. The name text we can anchor to the bottom center and put the Y position to 9. The width can be 62 and the height 20. Under the text component, let's adjust some things so that it dynamically changes the text size as necessary depending on the length of the item name. Check the auto size and set the minimum to 9 and the max size to 22. Go to the text alignment and set both the horizontal and vertical to center. Now that writing is a bit dark, scroll down and we'll adjust the brightness level by clicking the +1 on the intensity until it gives us a nice brightness. Okay, good. Now click on the outline as well. Once we set this, it will be the same for all the Text Mesh Pro objects, so we only need to do this once. And that's done. Now for the quantity text, let's go ahead and put that in the upper right. Anchor it there and set the X position to -31 and the Y position to -6.5. The width is 56 and the height to 10.5. In the Text Mesh Pro component, let's give it a numerical value like 10 so we can see how it will look. Okay, now we can safely give it a static font size. I think 10 looks good, and set the text alignment to the right and centered vertically. Cool. Now we can safely disable both of these objects. They will stay on the inventory slot, but will only be active when they are in use. Our next step is to create an inventory slot script that will handle all of the displaying of the inventory item and the use of the item in the future. Well guys, we're going to have to split this up into a couple of videos. After recording this and working on the editing, I found that this was running into a very long video for the inventory. So this is the first of the series of the videos for the inventory, but we made some good progress here. We now have an inventory displayed on the screen and are getting the building blocks in place for a great inventory system. I'm currently working on the next video in this series, and it should be up soon. I hope you're enjoying this tutorial series, and if you're getting something from it, please give it a like. It helps a lot, and it's free. Thanks for all the views, likes, and new subs. You guys are great. We'll see you in the next video.